consist of rational and irrational numbers. Further, rational numbers consist of natural numbers, whole numbers, and integers. Recall that you can perform all four fundamental operations, namely addition, subtraction, multiplication, and division on real numbers. These fundamental operations satisfy the properties such as the closure property, commutative, associative, and distributive properties for rational number. Let's explore whether real numbers too satisfy these properties or not. Let us check if real numbers are closed for the operation of addition. Let's take two real numbers, say -3/4, 5/7, and add them. What do you get? Yes, adding these two real numbers results in a real number. Just take any other two numbers and check. Hence, we can conclude that adding any two real numbers gives a real number. Since adding any two real numbers always results in a real number, we can say that real numbers are closed under the operation addition. Let's see if the difference of any two real numbers is a real number or not. Take any two real numbers, say -½ and 3/5. What do you get? The difference is again a real number. Here's another example. Thus, if A and B are two real numbers, then B subtracted from A is also a real number. Therefore, we can say that real numbers are closed under subtraction. Let's see if the product of any two real numbers is a real number or not. We multiply these two numbers and get the product, which is also a real number. Let's look at one more example. Observe that the product in each case is a real number. Hence, if A and B are two real numbers, then the product of A and B is also a real number. Therefore, we can say that real numbers are closed under multiplication. Consider these two real numbers. If we divide one real number by the other, the answer is a real number here. If we divide two real numbers by each other, the answer that we get is again a real number. That's why we may think that if A and B are two real numbers, then A divided by B is also a real number. What happens when we divide a real number by 0? Do you think real numbers are closed under division? Division by 0 is not defined in case of any number. Therefore, real numbers are closed under division if the denominator of the real number is not 0. Real numbers are closed under all four fundamental operations of arithmetic. numbers. Think of any two real numbers. Say 2 and 2.7. Is there any relation between the two numbers? Which of the three signs shown here can be used to show the relation between the two real numbers? 2 is less than 2.7. Let's now see any other real numbers. Say 91 root 2 and 91. Which of the three signs shown here can be used to show the relation between the two real numbers? 91 root 2 is greater than 91. Can you think of two real numbers such that one number is neither greater than nor lesser than the other real number? Which of the three signs shown here can be used to show the relation between these two real numbers? The two real numbers are equal. Can you think of two real numbers such that one number is neither greater than nor lesser than the other real number, and the two numbers are not equal to each other? There are no such two real numbers. Real numbers will either be greater than or lesser than or equal to each other. Thus we say that the set of real numbers is ordered. That is, if A and B are any two real numbers, then either A is greater than B, or A is less than B, or A is equal to B. What is the sum of these two real numbers? So, the sum of these two real numbers is 41 by 104. Let us reverse the order of these real numbers and add them. Will the sum be the same? Yes, it is. These real numbers can be added in any order, and the sum remains unchanged. We'll take another example to check if real numbers can be added in any order. Notice that the sum is the same no matter which order the real numbers are added. Thus, for any two real numbers A and B, the sum of A and B is equal to the sum of B and A. In other words, addition is commutative for real numbers. Do you think that subtraction too would be commutative for real numbers? Let's now check if subtraction is commutative for real numbers. We consider two real numbers, 5 by 8 and negative 3 by 7. Here, we subtract the second real number from the first. Then we reverse the order and subtract the numbers again. We see that the results are different in both the cases. Thus, for any two real numbers A and B, B subtracted from A is not equal to A subtracted from B. Thus, subtraction is not commutative for real numbers. Do you think multiplication is commutative for real numbers? Consider these two real numbers. We multiply them in different orders. We get the same result in both the cases. Let's take another example. The product of these two real numbers remains the same no matter in which order they are multiplied. Hence, for any two real numbers A and B, A multiplied by B is equal to B multiplied by A. Therefore, we can say that multiplication is commutative for real numbers. Finally, Let's see if division is commutative for rational numbers. Consider two real numbers. We divide these numbers in different orders. Observe that the results obtained in both the cases are different. The operation of division is not commutative for real numbers. How will you add these real numbers? Let's add 2 upon 5 and negative 5 by 7 first. Now we add the negative 1 by 3 to the sum. The final sum is negative 68 upon 105. Now let's add the same real numbers by grouping them differently. What do you think? Will the answer be the same? As we can see, the sum of the three real numbers is the same irrespective of the order in which we add them. Thus, when three or more real numbers are added by grouping any two adjacent terms, the result remains the same. This is called as the associative property of addition. Next, let's take another set of three real numbers and see whether the associative property for addition holds true for all real numbers. In this example too, we see that the answer is the same regardless of how the addends are grouped. Therefore, in general, we can say that for any three real numbers, a, b, and c, a plus b plus c is equal to a plus b plus c. Thus, we can say addition is associative for real numbers. Associative property helps us to add more than two numbers. Next, let's check whether subtraction is associative for real numbers. Let's carry out subtraction on these rational numbers by grouping 7 by 9 and 1 by 6 first. Now, let's group negative 4 by 5 and 7 by 9 and find the answer. Notice that the answers are not the same. Therefore, for any three rational numbers, a, b, and c, a minus b minus c is not equal to a minus b minus c. Hence, subtraction is not associative for real numbers. Now, let's check whether multiplication is associative for real numbers. Let us multiply these three real numbers by grouping negative 3 by 5 and 4 by 9 first. Now, let us find the product by grouping negative 2 by 7 and negative 3 by 5 first. We see that the product is the same in both the cases. Here's another set of real numbers to verify whether the associative property of multiplication works for all types of real numbers or not. Again, we see that the product is the same in both the cases. Therefore, for any three real numbers, a, b, and c, a multiplied by b multiplied by c is equal to a multiplied by b multiplied by c. Hence, multiplication is associative for real numbers. Finally, let's check whether division is associative for real numbers. We perform division over three real numbers by grouping any two terms. We find that in both the cases, the results are different. Therefore, For any three real numbers, A, B, and C, A divided by B divided by C is not equal to A divided by B divided by C. Hence, division is not associative for real numbers. We have seen that real numbers possess the commutative, closure, and associative properties. Let's explore whether real numbers satisfy the distributive property. There are two ways or methods to find the answer. Let us first multiply 3 by 4 to both the numbers in the bracket and then add the products to find the final answer. This time, we will first add the real numbers in the brackets and then multiply the sum with 3 over 4 to get the answer. As you can see, the results obtained using both the methods are the same. Thus, we can say that real numbers satisfy the distributive property of multiplication over addition. Distributive property of multiplication over subtraction. Let us first multiply 3 upon 2 to both the real numbers in the bracket and then subtract the products to find the final answer. Here, let us first find the difference of the numbers in the bracket and then multiply the difference to 3 upon 2. As you can see, the results obtained by using both these methods are the same. Thus, we can say real numbers satisfy the distributive property of multiplication over subtraction.